Alright guys, welcome to Continuity Part 1. This is video 1 in a two-part series, and today we're going to talk about what is continuity and the different types. And in the second video we're going to really discuss examples of how to determine if a function is continuous or not. In order for a function to be continuous, there are three things that must happen. Whatever point of interest you're looking at, f of c has to exist. Okay, the limit at the function at c must also exist, and then in this third step 1 and 2 have to be equal. That is, the limit of your function at c has to actually equal what f of c is. So in the third step here, 1 and 2, they're equal. So these are the three things that must be met. It's important to realize that if you just take normal polynomial functions by definition they are continuous. They would satisfy all three of these. Don't worry, in video 2 we're going to actually look at these more in depth and see when functions fail one of these and why the function is discontinuous. But today we're just going to look at the types of different discontinuities. Okay, so the types of continuities, and it's weird because they say types of continuities and then they're like, well, discontinuity. So the first one is a jump discontinuity. This occurs when the curve breaks at some point at a particular place, then picks up again later on. So here's the idea. If I have this parabola guy cruising, stops, right? He stops here and he picks up again and then cruises on to some other function. These are really common. This is really common in piecewise function. You see this jump. So you stop here and pick up again, and that's the idea. You break at a particular point in your graph and then you pick up later on. And that's what we call a jump discontinuity. Alright, the next one is a point discontinuity. This occurs when in the curve when there is a hole in it from missing a point because the function has a value at another point off the curve. Okay, and this would really actually fail Rule 2. Your limit here does not equal this value here. So this would actually fail Rule 2. But this is a point discontinuity. So here's the idea. I have this curve in red, and I have a break here for some reason. The function is not defined, and that reason being is the point is defined elsewhere. So I have this curve, I have a hole, I have a break, and then I pick up again on that same curve. But this happens because at A, I've defined it as some other point, and so it cannot be defined there. And that is a point discontinuity. Our third different type of discontinuity is called essential. The essential discontinuity occurs when you have vertical asymptotes. So you need to be thinking about rational functions here. So I gave you a couple of graphs, and they can occur in any quadrant, just with the vertical asymptotes, well, in quadrant 1 or over here in quadrant 2. But essential discontinuity occurs when your curve has a vertical asymptote. So just here's a couple of examples. So it's discontinuous. You can't draw the function without lifting your pen, and that's called an essential discontinuity. Our final discontinuity is similar to a point discontinuity. However, our point's not defined somewhere else. Point A is not defined somewhere else. This is removable discontinuity, and the idea here is it happens when you have again an irrational function. But you have common factors in both the numerator and the denominator, so you remove that vertical asymptote and you have a gap, you have a hole. So at A, for example, you have a hole. Maybe this was the graph of 1 divided by x, maybe x minus 2 over x squared minus 4, and you can remove one of those factors and we have this hole. Notice how there's no other point defined at A. So this is not like point discontinuity where this value of A is defined somewhere else. A is just not defined. It's not in the domain. So this is another discontinuity because we have a stoppage and we pick up again and we have a hole there, and the function is not defined anywhere else at A. So those are your types of types of discontinuity. We have jump, we have point, we have essential, and we have removable. So if you see any of those four, then your function would not be continuous. And so in video 2, we're going to look at examples where each of these four discontinuities occur, and then we'll use those three conditions that we need to be continuous. Because when you talk about these removable when you talk about these discontinuities, they fail one of those three rules. F of c exists, the limit of as x approaches c of f of x exists, and then you remember that third condition, the limit at that point has to equal the evaluation at that point. So they will fail one of those three. So that's it for continuity part 1. If you have any questions or comments, please email me at nicholas.bennett@dc.gov, or you can make your comments below. Thanks. Bye.